Okay, ladies and gentlemen, we're going to finish the 1.4 material for Math 1033. There are two problems left. This problem that we're looking at now, y equals the cube root of x minus 5. You're given the x values in the table, but you're not given the y values, so you're asked to complete the table. Very important thing when you're reading this formula. The cube root of x is to be done first. Then the minus 5 happens after you've taken the cube root of x. In other words, the minus 5 does not have anything to do with what's under the radical. Notice it's away from the radical, it's not under the radical. So, when I take the number -1 and I'm evaluating this formula, what I'm told to do is to take the cube root of -1 first and then subtract 5. The cube root of -1. What times what times what gives me -1? That answer would be -1. The cube root of -1 is -1. -1 minus 5 is -6. So this is how you approach this problem. You take the cube root of the input first, then subtract 5. Look at the next example. The cube root of 0, since we're plugging in 0. What times what gives me 0? Well, that would be 0. So the cube root of 0 is 0. 0 minus 5 is -5. That's how come when we put in 0 for x, we get out -5 for y. And so on. So let's look at the next few. When I put in 1, for example, as input, the cube root of 1 is 1, because 1 times 1 times 1 is 1. 1 minus 5 is -4. So for an input of 1, in other words, when x is 1, y is -4. Cube root of 8. What's the cube root of 8? What times what gives me 8? That would be 2. 2 minus 5 is -3. So for an input of 8, for an x value of 8, my y value would be -3. And finally, when I plug in 125 for x, that's input, the cube root of 125 is 5, right? Because 5 times 5, there we go. 5 minus 5 is 0. So for an input of 125, the output is 0. So this is how you determine your outputs to that problem. Okay, this problem about the bird's weight, don't let the words intimidate you. What we're looking for here is basically you understanding how to work with the formula and what the letters mean. So the wording in the problem isn't meant to intimidate. The wording in the problem is meant to inform. So you need to let some of that garbage go from your past about seeing a worded problem and panicking if you used to do that. Read the problem, check off what the things are telling you, what they mean. So W in this problem, in this formula, W stands for a bird's weight in kilograms, and L stands for the bird's length, the bird's wingspan length in meters. Okay. First question. If a bird has a wingspan of 0.54 meters, estimate its weight. Estimate means use a calculator. 0.54 is the length of the wingspan, so we put that in for L. So come down with me to this part of the paper. Here we go. So we end up getting W equals 1.3 and then in parens 0.54 raised to the third power. In other words, we plug into the formula. Now, if you know how to use a scientific calculator with your power key, you should punch your way to happiness. If not, get some help at the Learning Commons, ask your instructor, ask a fellow student. But do learn how to use your calculator. The reason we're able to use our calculator here is because the word says estimate. That means approximate the answer. And we come out with an approximate answer of W equals 0.20 kilograms. Now in part 2 of the problem, sometimes this really freaks students out. It says, what happens to the weight when the length of the wingspan doubles? Well, a really easy way to see that, first of all, is let's start off with what happened. Notice I've got my cursor on the word doubled. We're no longer plugging in 0.54 for L, we're plugging in 1.08. And that's by taking 0.54 and doubling it. In other words, multiplying it by 2. So, my formula now has a different input. When I use my scientific calculator and I do the computation 1.4 times quantity 1.08 to the third power, I come out with approximately 1.6 kilograms. Now, please don't stop there, because the question did not say, in part 2, the question didn't say what is the bird's new weight. The question said what happened to the bird's weight. Okay, this is a comparison. If I have 0.20 as my old weight and my new weight is 1.6, if I asked you what happened to it, you would see it got bigger. How much bigger? Well, if you take 0.2 and you multiply it by 8, the new answer would be 1.6. So one way to see it is to just observe. Multiply by a factor of 8. Another way to do it on your calculator to get that the correct answer is it's 8 times bigger. What's the new weight? Approximately 1.6. What was the old weight? Approximately 0.2. If in your calculator I took the old weight, if I took the new weight, which is 1.6, and I divided it by 0.2, notice that you would get the answer 8. So that's a good way to do it. If you want to know by how much something has gone up, take the new weight, divide it by the old weight, and we see in this case it's gone up by a factor of 8 times. Okay.